their issue? Has this person continued to play?
Hey, there we go. Oh, am I back up now?
They
Okay. Yeah, okay. Weird. No idea what just happened there. Okay, so we're going to just run this again. Now that we fixed that one little thing. Although, yeah, I was looking to see if other streams were up. Alright, we're going to try and win one more time. We're going to go with 0 so that we take this one. Ooh, it made a move. It decided it was going to go right next to me. I find that somewhat surprising. Isn't it if I play here, I'm guaranteed to win now? Maybe not. Yes, I am absolutely guaranteed to win if I play in 2. And then, again, it chose the weirdest choice. Weird. Alright, time to start printing stuff out, right? There's got to be a bug somewhere. Because I'm about to win. Let's go with 4. Hey, the player, the winner is number 1. Okay. Okay. So what we want to do is on the step where we actually print out the winner, right here, I think what I want to do is say dot select new tree dot simulations count m.simulations count dot to array, and then we're going to say move stats, and then we're going to say print, okay, for each var move and move stats, and I need to keep the move. Move equals m, and then sims equal that. Hey, here we go, we're back. You're back. Hearing voices. Isn't this the entire premise of war games? This is the only correct move is not to play. Okay, so now we're going to say console.writeLine, and here we're going to do a little $sign. We're going to say move.move. I'm going to just say get hash code, I guess. Just something to like uniquely identify it here. And then move.sims. and then selected move, move stats dot first dot move. Okay, so now at the end of every time that it makes a choice, it's going to print out some information about it. And in fact, I'm just going to put the whole stats in here so that I can do dot simulation count and move dot sims dot wins. Okay. And let's put this one to the left because it'll make it a little bit easier for me to do this math in my head. All right. Now let's just do it. Okay, we're going to go with 0. Ugh. Failed to compare two elements in the array. Sure. Sims.simulation count. There we go. It made the same move. Oh, wait. So this is exactly the problem that I was hoping to avoid. It never chooses the other moves because on the first try, it wins the very first one. So from a pure Monte Carlo standpoint, this is atrociously negative because it found a winning move and then it never lost enough to push it back far enough to try any of the other moves. Okay, so this is... I had a to-do in here. Which is right here. Okay. Should this be what it's set to initially? I don't know the answer to this. I think now, like... I think the answer is to just go like this. Simulations count equals 0. Then we want to do 1D. Otherwise, we want to do this actual calculation. So basically what we're saying is the very first time you see this thing, you should try to expand it your damnedest. This feels wrong. A little bit. I want to force it to choose this other simulation. I don't even know what to say, Surly Dev. Oh, I had a weird dream once that I sat in a hotel bar discussing farts with Matthew Broderick. That is interesting. I don't have dreams like that. I haven't had dreams like that, I guess is the best way to say it. Yeah, so I don't know the answer here. This wasn't super well covered. Which is, what do you do when you encounter a state that you've never been to before? What do you do when you encounter a state that you have never been to before? How do you treat it? Do you treat it as a must expand? I thought 0.5 would be good. Because if you find something that's an obvious win up front, you want to just do that. I guess we're just going to try it like this, where we're going to try this again. Now it's going to force it, I believe, to try all of the moves before it will continue going down the same path over and over. Maybe? Please enter your selection. I want 0. Okay, that's a different move. Look, that's a different move. Okay. So this time, it thinks it can win with almost 100% accuracy. I also am not understanding how on earth this could possibly be negative. Like, seriously not understanding that at all. Because I'm the one that implemented the value. But somehow it thinks that it is going to win. If it makes that move. Now I want to know what this move is. You know what we're going to do? We're going to print the hash code of the current state. Let's kill this. Let's go to the program, play game, make move. The human player, the console player, current state, and we're going to put a little $sign here, and we're going to put a little parentheses here, and we're going to put a little this, and we're going to say current state dot get hash code, so that we can actually see the hash code of the current state. Again, I can't for the life of me understand how they could possibly be negative. Probably because I started off with the hash code of -1. So hash code equals 0. And that'll fix that problem. Okay. All right. All right, the current state is 0. There's no move, so we choose 0. Let's make this bigger. It, this time, decided to try 6615, which was right here, and somehow it thinks it's going to win. Basically it thinks it's going to win no matter what the hell it does. Look at this shit. This is ridiculous. It thinks it's going to win. You know what? I think I'm doing the winner wrong. I think I am. I think I'm doing the winner wrong. Let's take a look. Okay. If we go to Monte Carlo tree search, right here where I'm applying the score, this one makes sense. But whoever's turn it is, did not win. Let's try it like that. Okay, so for those of you who are following along, the idea here is if the game is over, then we are in a state where I have made my move and the player's turn has been updated to the next player, but they lose. Is this right? It's the right way to say this. Unit test. Yeah, I don't have unit test, do I? Okay. Let me put it to you this way. Well, actually, I don't know. Let's just see what it spits out this time. Okay, yeah, it thinks it's gonna lose all the fucking time if I do it this way, or it thinks it's gonna win all the fucking time if I do it the other way. Just for the sake of argument, maybe it's right. No. Because all I have to do is play in the middle here, and I guarantee myself a win. Because if it plays here, then I play here, and I have a win here, and I have a win there, and it can only play in one of those two slots. Okay, so the answer is no. Let's go back to the other way. Okay, in this one, it seriously thinks it's going to win 100% of the time. 981 times out of 982, it found itself winning by playing right here. If it plays right here, then all I have to do is play in the middle, forcing it to play here. Then I play here, and guess what? I have forced a win for me again. Because I can win here, and I can win there. No, there's not 982 moves. It's playing 1,000 simulations. So 982, 992, 94, 96, 98, 99, 100. It is actually finding ties in some cases. This is feeling like the scoring is incorrect, right? Like that's what this is feeling like? That for some reason it always thinks the last person won. So I'm going to say that is terminal spitting out the winner is not spitting out the correct winner. Almost 100% of the time. So I do think there are unit tests for that. Program is terminal okay. Expected. If not, is terminal. Winner is player 1, winner is player 2, winner is none. I guess one way that we could do this is we could just see that it is actually spitting out valid follow-ups. So something's got to be wrong with my, something has to be wrong with my game implementation for it to be that bad. It's also possible that I screwed something up in here. Well, no, this one I think is actually okay because get hash code should definitely only be get hash code should definitely only be unique. Okay. is terminal. Current player's turn equals player ID dot none. I could see that being an issue. So you start with player 1. Determine winner. Given a board, just determine whether one of the players won or not. What is possible winner? Equals board. The hell is cell group? Winning batches. Ah. So what we're saying here is... Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8. That makes sense. 0, 3, 6 is vertical. 1, 4, 7 is vertical. 2, 5, 8 is vertical. 0, 4, 8 is diagonal. 2, 4, 6 is the other diagonal. Now it's saying determine winner says for each possible set of locations that could have a winner, get the value of the first one, and if it's none, then you bail. What's your reward function for the game? It should just be a 1 or a 0. Or excuse me, yeah, a 1, a 0, or a 0.5. But the trouble right now is unquestionably it thinks that it's going to win like every fucking time. Excuse my language. It thinks it's going to win every single time by playing right here. And it is trivial to show that that is not true because all I do is play in the middle. It's forced to play here to prevent me from winning. I'm forced to play here, which is great because it gives me a win right here, and it also gives me a win diagonal. It can only play in one of those two locations. I'm guaranteed to win. And for some reason, it thinks it is going to win when it plays there 981 out of 982 times. Which is wrong. I have no idea where 8019 is, like which state that is. I guess we could print it out. Let's go ahead and print it out. Console player for each successor I. We're going to $sign this. We're going to go I. And then we're going to put this in parentheses, and we're going to go successors of I dot get hash code. So all I'm going to do now is look to see where... Okay. Oh, it didn't work out quite as well as I was hoping. It's not actually showing me which of the other board states it is. It is showing me which one it chose, which in this case if I go here, actually this one, that is a good location. But it still thinks it's going to win most of the time. Okay, I am going to say what am I going to say? We don't want the console player. I don't care about the console player. I care about verifying that this is correctly setting if oh, in a tie, it's always setting it. Here's the problem. All right. If it's none, if the winner is none, then what we're doing is we're saying check that there is. All right. If there is no winner, and there is any open spot on the board, then we want to set the next player. Yeah, no. Otherwise, we're. I don't know the answer. Let's just go and find an example that's broken by debugging. And then let's this does technically terminate it. So the current setting the current player's turn to none ends the game. I am going to guess. Well, okay, I'm not going to guess. I am going to step through the game, and when it gets to the point of doing back propagation, I'm going to watch it walk up the tree. That's what I'm going to do. When we get to the point of back propagation, I want to watch it walk up the tree. I don't know how to do this. I think I need to do something like debug.net core. Start debugging. No idea if that's going to work. Okay. We're going to put in a 0. I can't tell what happened. Look, see, the source code is different from the original version. What? What? Oh, let's see. .NET build. It's not anymore. Put in a 0. I don't know what's going on. What if I click pause? What? What? I honestly don't know what's stuck here. play? It's waiting for me to input something. Is this not the debug console? I don't know what to do. It's still running. Okay, new idea. Instead of having a human player involved, we're just going to have two Monte Carlo players. That's all. Assuming I can find it. There we go. Okay, view, terminal. No, I need to debug it now. Console.readline expects input. Was I not putting it in? Hey, Codephobia, what's up? Okay, look. What? This is still expecting human input. Which is wrong. For some reason, it's still hitting a console player. Okay, let's go take a look at VS Code launch. .NET Core launch. Pre-launch task build program. Oh. Ben, we need this .NET Core 3.0. That's not frustrating at all. And it's an exe. Wow, that's frustrating. Let's try that again. Johnny 5, need more input. Hey, all right, there we go. Okay, back propagation. Okay, so we have this path of all these game states. Hooray! And in the board, we have player 1, player 1, player 1. Which is the first row going across. So the winner is player 1. That's correct. Uh-huh. So we now have a path. This is not super helpful at all. Okay. No winner. Oh. Okay, so my winner is player 1. State.current player's turn. What is the state on this one? An empty board. Okay, so player 1 did win. In states, there are 10 states, which actually seems like kind of a lot. No. Value. There should not be... Okay, I can't understand why... Oh, there are 10 states. There's the initial state, and then there's the 9 next states that you could possibly go to. Okay, so this makes sense. So in this case, player 1 did win, which we can verify because they played the top row. The middle row is a blank, a player 2. The bottom row is a player 2, and then a player 1. Okay, so this is a win for player 1. That is correct. And now when we go up to the top, it's the first player's turn. I think I do want it to be the opposite. At the root, which is where we're currently at, which we don't need to make a decision, if we're going to choose the path that we won the most on, then the scores for the next one needs to be the player who just made the move. I think that's it. The player who just made the move. Let's take a look at the example again. It's black's turn to move. So we're on the white state. Black's turn to move. Okay. So it's my turn to move. And all I care about is my chance of winning. Okay, so I think the answer is... I think the answer is not equal here. Oh. Okay. 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 When we do the selection step, what we need is from this state, my chance of winning is from this state, the current player's chance of winning is if the current player makes this move, having trouble keeping all this in my head, and maybe that's a bad place to keep it anyway. All right, so if I'm in this position, I don't care what my chance to win is. I care what my chance to win is from the next position. So let's go to tic-tac-toe, and let's say public player ID last player's turn, get private set, equals player ID dot none. It's Friday and I don't have the brain capacity for this. My eyes are just glazing over. I kind of feel the same way. I'm like, I just want to make a tic-tac-toe game on the computer that cannot lose to me. That's all I want to do today. I thought it wouldn't be that difficult. So we have the last player's turn. We have next state. Current player's, no, last player's turn equals current player's turn. Okay. And then I think what's happening here. Oh, okay, okay. Another issue. From the thing is when there is a tie, you have to randomly choose amongst the ones that tie. Okay. So Monte-Carlo tree, I don't even need the player anymore. Don't need the project, don't need the interface. So up here where we actually choose the move, what we want to do is say successors. Var best score equals -1D. Okay. I would say for each var successor in successors, we say var stats equals tree dot states of successor. Then we say if stats dot score, no, dot simulations count okay, int, was it an int? Double. Most simulations equals -1 f d. If this is greater than most simulations var best score states equals new list iGame. I want this console.log right here. Not move. Successor. Successor. Oh no, stats. 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 If stats.simulation count is greater than, then we want to say best score states dot clear, best score states dot add successor, and success best score, no, most simulations equals stats dot simulation count. Else, if stats dot simulations count equals most simulations, then we just say best score states dot add successor. Okay, that gets us the best, and then we need to choose a random one. Var selection var next move equals best score states, and we're going to index that by random dot next of best score states dot count, and then we're going to do next move. Okay. So this handles randomly selecting amongst states that have the same score. Just a flat random of those. Okay. That still doesn't tell me why it keeps selecting the highest score over and over and over again. Or why it thinks it never loses. I think, alright, so when we start marking up the score, so the back prop, I think what we want to say is on the final state, the player's turn is none. Why is current player's turn not on here? iGame. Where is my iGame? Close all this crap. Tic-tac-toe. iGame. Current player's turn. Last player's turn. Okay, so when the game state is complete, and we want to determine, so on the last state, the current player's turn is set to none, and we want to know who the last player's turn was because that was the person that led us to this state. Yeah, this feels right to me. Okay, one more time with feeling. Let's go back to the program. Let's play. View. Terminal. Sure, close it. .NET run. .NET build. Tic-tac-toe does not implement last player's turn. Feel like it did. Last player's turn. Let's try that again. Oh nope, still complaining. Last player's turn. Okay. Okay. Oh, and look at that. Look at that. This time it chose the middle, which is the only spot that it can win. Everywhere else is a guaranteed victory. No, that's not true. The top right-hand corner yeah, actually. If you play in the top right-hand corner, then I play in the bottom right-hand corner, which forces you to play in the middle, which forces me to play right here, and then I have 2 wins set up. So I still win. Okay, so the only way to prevent a loss is to play in the middle, and it figured that out this time. Okay. Woo! Let's see if it's really figured it out. Right? So I should play... What happens if I play right here? It plays up here, which means I play down here, which means it plays over here, which means I play over here, and then it doesn't really care which one it plays in. Okay, let's try it out. So we're going to go with 0 again, because 0 is the one that will do this. Aha! It figured out to not lose, so it decided to play up here. But in this case, it thinks it's going to win. Have I done something wrong? It definitely feels like it thinks it's going to win. Okay. Let's go with 2. I put it in 2, so I played down here. And then it decided to go here, thinking guaranteed tie. So it went from this one on thinking it was going to win every time to thinking it was going to tie every time. Which is correct. So now I play this. So now I play 0. And there's only one choice. And we tied. Okay. Okay, so this is good. It tied me. Now I want to let it win. I also want to come back. I'm going to write down this one state because this one state is bothering me where it thinks it's going to win the whole time. It thinks it's going to win the whole time. Okay. So let's put that on my little to-do list here. All right. Figure out why it thinks it's going to win the whole time. Okay. Put that over here. And then let's see here. And this time I want it to win. 0. Okay, it found the correct spot again, thinking we're going to tie the whole time. I'm again going to play up here at the top. So 0 again. It again. Oh, look, this time it correctly figured it out. That is interesting. So there's got to be some kind of like latching that's going on where it like finds a path all the way to the end and then it's just like I can just keep going down this path. So there's got to be like a little edge case in here or something. I bet if I were to like run this, 50 times and get to this 50 times, which is actually really easy to do, that we would find out that it was most of the time doing this, or like some percentage of the time doing this, and then some percentage of the time latching, thinking there was just no way it was going to lose. Okay, I want it to win. So I'm going to play right here and see if it actually finds the winning spot. And it did. Alright, well that's a good sign. Now let's go ahead and set up that board and see if we can figure out what in the hell is going on. So the board that we care about is XXO blank O. XXO blank O. Let's do static void debugging test. Okay, this is going to be expected. I don't want this at all. I want 0, 0, 1, 2, 3, 0, no. Okay. 0, 4, 1, 3. No, 2. And that's it. Okay. I don't care about the winner. What I care about is for int I equals 0, I less than 10, I plus plus, monte-carlo tree search, monte-carlo tree search dot search of state and 1,000. Okay, I'm going to have to wrap this up here in about 3 minutes. So I'm just going to run this. We're going to see if it's like sorted itself out. I joined late. Would be great if you explained how you do the Monte Carlo tree search, what it is, how it's beneficial, etc. Sure, give me just 1 second and I will do exactly that. I'm just going to run this real fast to see if like maybe there's a bug or maybe it's okay. View, output, extensions, console, terminal, .NET run. Okay, and I need like a break in between these. Console.writeLine. I can already tell though. Okay. Yep. Absolutely what's happening here. So in this case, it's like it thinks it's going to lose all the time from this state. In this case, it thinks it's going to tie accurately. In this case, it thinks it's going to tie accurately, tie accurately, tie accurately, tie, lose all the time, tie accurately, lose all the time, and lose all the time. And if we keep doing this over and over, I would have no doubt in my mind that we'll find an instance where it thinks it's going to win all the time as well. But I'm not seeing it yet. Okay. All right, so Monte Carlo tree search, in short, is basically a way of empirically deciding what the next best action will be. So you take your current state, you have a simulator, and what you do is you take your current state and you run it through this simulator, say 1,000 times, and you record each of your different actions, what your percent win rate is for each of those actions that you do, and then you choose the one that leads to the best outcome on average. And that's the like general idea. Monte Carlo tree search builds a tree of states, and it's got a lot of like, I don't know if extension points would be the right way to say it, but basically like the way that you decide which branch to take. Right now I'm just choosing completely randomly, but there are better ways to do it, where you can, say, create a value function for any given state and then choose the highest of your value functions, and then hopefully have your value functions update as you go, so that you're not just, predicting your value function. And then another thing that you can do is, sounds great, in what scenarios is it particularly good in? Well, the thing that got me started on it is it's really good at playing games, right? The world's best computer chess player uses Monte Carlo tree search. And I was hoping today just to build something that could at least tie me every time in tic-tac-toe. Like, that simple. And then maybe later on to sort of expand it into a more difficult game. Maybe like Reversey, if you're familiar with that, or Othello is another name for the same thing. It's an 8x8 board. You put a black or white dot. To see if it would still perform well and could beat me in a game like that. Or if it just falls apart, like what the holes are, where it starts to suck, where you need to like plug in and put some more smarts into it, just to sort of get a better understanding of how to use this. Like conceptually, super, super simple, but yeah, I just don't know that much about it, and I wanted to learn about it. So that's what we started doing today. All right, so there's definitely still a bug here because it thinks that, well, this might actually be true. Okay. All right, so here's okay, no, this is not actually failing. This is doing exactly what it should be doing. Let's talk about why it is crapping out. Okay, so in this case, the best move is actually this middle one. Right here. And the reason that this is failing is because the very first time that it tries it, it finds a loss, and it finds a win randomly on any one of the other ones. And because this is not weighted by the amount that we have explored it, any given win here will always be better than a first-time loss somewhere else. So we will never explore this branch again. We will always explore this branch. And yes, this one does actually lose almost all the time. So it's only when it finds that the correct one is a tie and doesn't manage to lose that game in a random playout on the first try that it actually finds the correct solution. So that's what we need to do. And actually, that's what the next step is. That's what it starts to talk about down here, which is you move away from pure Monte Carlo game search, and instead you move into this exploration exploitation with upper confidence bound and UCB. And you implement this as a weighting function, saying that, okay, we've seen this one a lot, so we're really sure about the score here, but we haven't seen this one very much, so we're going to give it some additional benefit. And occasionally we're going to try this. And what's going to happen when we try it is we're going to find out that, okay, the second time we try it, instead of randomly choosing the loss route, we get the tie that we should have gotten. And that tie will be enough to overcome the value of this huge loss, because this is a very small number. 1.5 divided by 996 is a very small number. And like 0.5 divided by 2 is a much bigger number than that. So all we need to do is find a way to continue exploring these ones even when we crap out on the first try. All right, so there's no problem here. It's just we just need a better exploration method. And that's it. Okay, I actually feel really good about this. I feel like this was a lot of progress. I'm going to go ahead and check this in. let's go ahead and check this in. Monte Carlo, no, pure Monte Carlo. Carlo tree search impl. And if you want to play around with the code that I've got here, I can't help thinking a GUI would be good. Yeah, it absolutely would. It absolutely would. Yes. I love the projects you've done this week, Nick. Varied and challenging to think about. Thanks, man. I really appreciate that. I think, yeah, I think on Fridays we're going to keep doing more of these sort of like off-the-wall, never done it before type of things. Want to just try something new. And I want to wrap up some of the projects that we've been working on as well. Man, if you could add an Angular front end to this, that would be amazing, and I would love that. I am checking in the code at this very moment, and assuming it actually pushes up, you can find it on my GitHub. And if you go here, you should start on Skynet next week. Okay, sure. If you go to my GitHub, you'll see that it is now checked in there, and yeah, you can just grab this and start, grinding away, do whatever it is that you want to do on here. Actually, here's a full link. Be a little bit easier. Perfect. Okay, I would like to thank everybody for coming to hang out. We made progress toward my learners goal for the month of 300. We are at 295, only 5 away, which is awesome. Thank you, everybody, for the raids. I really, really, really appreciated that. Ardalis, thank you for the raid. Zeratar, thank you for the raid. Those were amazing and so much fun. And thank you, everybody, for playing along all day. Let's go ahead and find somebody else to go raid. If you have any suggestions, I am all headphones. Let's go with Jitter Ted. It looks like he's doing a bit of planning today for a project, so might be fun to check out what he's doing. And I will see you all very, very, very soon. My normal raid times are Wednesdays, Thursdays, and Fridays from noon until, well, whenever. And that's it. Thanks again. I'll see you all next week, hopefully. Bye.